The next speaker is Sobolev and his team, and millimeter and submillimeter transient events in star formation. We are listening you.
Okay, so this is a review talk rather than the talk which is summarizing our results. Yeah.
Are you ready?
Yes, but you don't hear me.
Dear Andre and dear Ivar, Andre, we are hearing you.
I hear you.
Okay.
Yes,
Yeah.
I hear you.
Yeah, but you didn't hear before.
Yeah.
I addressed it several times. Okay.
Okay.
So this is the review talk rather than a summary of our group or something other thing research, but this wants to draw your attention to necessity of monitoring and the studies of transient events and what can this monitoring in millimeter and submillimeter tell us. First of all, what is transient? A transient event carry information on the sudden changes in the objects. So their characteristic times are quite short. This is definition of the transient event. And sometimes we can observe the whole duration of the event, which is not possible for many other for many other events. So these transient events are kind of phase transitions because the changes are quite sudden. So they carry information both on the prior and post-evolutionary phases of this event. And this makes the studies of the transient events very informative. And so monitoring is the only way to register and study transient events, because you need to show that it is transient, that it is short-lived, and these are quite sudden and great changes. Monitoring requires considerable observing time, especially for the studies of rare and long-duration events. Observing time of the millimeter and submillimeter facilities is quite expensive at present, so the era of extensive millimeter and submillimeter monitoring should come in future. But in this talk, I'm trying to say that it is very important, and we have to look forward for this monitoring in future. Anytime, even now, some research on the millimeter and submillimeter monitoring is ongoing and brings very good fruits. There are different types of monitoring, spectral, photometric, and so on. And the other type is all sky. These are using surveys like WISE, Gaia, CARI, and other things. There are monitoring of selected areas, which are maps. So we creating maps and looking at the maps of selected areas with some chosen cadence. And there are also selected targets. When we are looking at this only selected target, or probably in one point, and then we see how it is changing. Then very important one is a triggered monitoring. Triggered monitoring is very important for millimeter and submillimeter because we cannot use very much time of the modern facilities in millimeter and submillimeter range, and we need some other trigger which can tell us that something transient event is taking place and something interesting is happening. So type of all sky monitoring is, for example, this one. So looking at the catalog of WISE catalog, the people in this case, these Uchiyama and Ichikawa-san, they discovered mid-infrared variability of massive young stellar objects. But this is at present a good way to do, but not yet well studied. Then selected areas maps. One of the best examples of monitoring of selected areas in millimeter and submillimeter range is the Jcnt transient survey. So this shows you a collection of the papers of this monitoring. So what's it? So firstly, they concentrated on the monitoring of low mass star formation regions. They have selected 8 regions of low mass star formation containing many protostars and many disk sources and other things. But now this was a 3 years monitoring, which I'm telling you now, because these results are published. But now it extended to 7 years, and they included in the monitoring 6 high mass star forming regions. And we will see what will happen in future. We are looking forward for this. So what, first of all, why they were wanted to do that? Because there is mass accretion, or which provides very fast variability, and tells you a lot about the construction of the sources and their nature, their structure, and so on. And so they were trying to find such an events. In fact, within the 50 months, which I'm explaining now, they detected mostly secular monitoring, secular variability. And we see that, there are no really transient events. There is some monotonic changes with the, so they are quite secular variability. This monitoring is carried with the cadence 1 month cadence, about 1 month. Okay, and when we look at the variability in the 850 micron in Jcnt and compare it with the 4.6 micron light curves of WISE, we see that the changes in the 850 micron are much smaller in the value, and it is difficult to detect. But they are also still they are very, very interesting. So here you see that one variability, and we see that, for example, submillimeter monitoring and K-band, L-band infrared monitoring show that the peaks in the submillimeter and the infrared shifted a bit, and this has to be studied, and carries a lot of information about the background of the source. In this survey monitoring, there was detected really truly transient event. It was very lucky chance. So there were 20 epochs, and only in 1 epoch they detected this source. You see this source which appeared, and it is very interesting that that the integration was 30 minutes. And with this 30 minutes, the source changed its brightness 2 times. So it faded away by 50%. So if we would make such observations more frequently, of course, we could detect much more such transient events and tell a lot. What this tells you, for example, this tells you a lot about the star itself. The flare, which was, they say that was magnetic reconnection events, but was 10 to the 10th times brighter than typical solar flares. That means it is very important, and we have energetic estimates and other things. Okay, so what's further? So there are some future which is described here, but it is not realized yet, but we will see. Okay, so selected target survey. So this is requires you a list of individual sources which are monitored with some chosen cadence. So the oldest surveys were carried out at Pushina, so these are more than 30 years now, at Medicina and Hartrau. And of course, since we are now at the conference at the Ventspils, we have to mention that there is a very good and interesting monitoring which is carried out with the Urbana 16-meter telescope. And of course, what was already reported by Anna Bortkiewicz, this is a monitoring of Torun, which is carried out at Pivnice 32-meter telescope. Okay. So triggered monitoring can be of different types. One of them is that we can expect something. For example, this source is how to say, is we know when the event will take place, but we know it's by observations within several years. So now we can predict when it happens. In this case, we can make observations in the infrared or in the submillimeter, and it was carried out. You see here the result of the observations with the Spitzer telescope, and we see how the light echo of the source is propagating through the surrounding medium, and it is we have to study. We see the structure of the source. We see interesting events, interesting effects, but this has to be published in future. Okay, so masers are very good triggers for the studies of transient events in the infrared and the millimeter and submillimeter. Just because these observations are relatively cheap, and the many sources are monitored in the centimeter wavelength. So, but masers are related to some special parts of the surroundings of the star-forming objects. So some of them are in accretion disk, some of them are in the outflows, and we have to look into this and try to monitor as many transitions as possible, of course. One of the very good examples of this maser triggered study is studies of S255, when we have seen first the bright flare in the maser, which is shown to the left, and then we also see the flare in the near infrared. So we see here in the image left the pre-flare, and then during the flare, so the image is greatly changed. So in this case, the variability was the result of accretion burst, and this accretion burst phenomena were predicted several times, and we see them, and they have theoretical explanation. For example, this one, so this paper, which tells you how much and how fast, how often they can happen. It was very interesting that this triggered by the centimeter single-ish monitoring. First, after that, it was observed with VLBI, and it was shown that the masers changed their position. This was discovered for the first time, and this tells you that the excitation propagates through the medium, and we see how far it propagates and which effect it produces. It was interesting that during this event, the ALMA observations were carried out, and they have resulted in detection of really submillimeter maser. This is 349 gigahertz. So this also can be monitored, and we done some more observations of this line, and we see that it is changing it, but this has to be reported later. Another monitoring of the centimeter lines was the monitoring of very contemporaneous flaring in hydroxyl methanol and water masers in NGT 6334-1. It's actually 1, not I. So then it triggered observations with ALMA and and SMA, and you see here the series of images which shows you that really which one of the sources was brightened, and to which extent. This tells you a lot about the how much mass was accreted, and about the energetics of the events, and about the how to say spatial span of these events as well. So here we see what happened during the burst and what happened during it before the burst, and we see that there are changes which are mostly seen in the infrared, mid-infrared, and far infrared. Okay, so then since this was very important, so the maser monitoring organization was created, and it happened. It helped to detect very important new events which are related to accretion bursts. For example, this was accretion burst in G358, and so on. Then, except for monitoring in submillimeter, it was VLBI monitoring which have shown that the region of the maser expanded, and the masers greatly changed their position. What was very important that it was found that the distribution translocates with 4–8% of the speed of light, not with the speed of light. This means that the excitation goes through structures with very high density material, and this effect has to be studied further. So during this, they have also shown that the secretion goes along the spiral structures, and this was very important. But this was, how to say, this was triggered by the centimeter maser monitoring observations. And then observations with ALMA and SMA have discovered a lot of new maser transitions in the submillimeter range and millimeter range. And this is very important. And this shows you these maps and so on. But it is interesting that the ALMA range, the source which is associated with masers was not variable. This is was very unexpected. But anyhow, so these ALMA observations were carried out in 2 epochs, and we see that this is the distribution. So this is upper row and the middle row, that the distribution of masers and their morphology changes during the accretion event greatly. And the further observations in this range, they have very high potential to study the surroundings of the source. You also see here something like spiral strokes. Then SOFIA observations were triggered by these centimeter wave maser observations, and these data have shown that this is a really accretion burst. And in this case, it is interesting that this accretion burst can be detected only in the far infrared, but it is not seen in the mid infrared. It is not seen in the near infrared. It is not seen in submillimeter range, only in the far infrared. And in this case, these observations allowed to study how much mass was accreted and so on. And here is in the lower row is shown a model which explains these changes and so on. So it is very interesting that that in the 3 events which were studied up to now, accreted masses were masses of Jupiter. The first one is 2 masses Jupiter. Then the 2 other events, though they're very bright, they were less than mass of the Jupiter. So these are not stellar masses, which while the current models predict accretion events of the greater scale. So these stellar masses should be accreted. We probably will see this in future. Probably not. In this case, we'll have to change our models to look why the accretion events are taking place with non-stellar masses, but with the planet masses. So currently obtained results of the maser triggered stars, there's a maser studies combined with observations in the far infrared and submillimeter millimeter range have shown high potential for the studies of the structure of the circumstellar disks of massive young stellar objects, including their kinematics and magnetic fields. They have shown that the structure of circumstellar disks is significantly inhomogeneous. They contain coherent structures up to 1000 EU in size. Accretion of matter onto a young star can occur along some structures. These structures can be in the form of spirals, which we've seen in one of the objects quite clearly. The matter of accretion structures in inhomogeneous accretion of matter on the young star leads to luminosity bursts of various intensities. A large amount of high density matter is present in the disk structures, which leads to significant slowdown in the propagation of the energy released in the accretion burst. And this was not studied, but this is a very well-known effect for the propagation of light within our sun and within the stars, but not within the interstellar matter. This was discovered first. After the accretion burst, the physical chemical state of the disk change and doesn't return to its previous state, just because we see that the masers change their positions and don't come back.
Andre, it's, 20 minutes are gone, but we can do give you, of course, I suppose, a couple of minutes.
This is the end. So
okay.
Some future. So continue maser monitoring triggered research with M2O capabilities. There's many maser monitoring organization, including interferometric with VLBI, EVN, ATCA, and other millimeter, submillimeter, ALMA, SMA facilities. So relevant proposals are, are accepted already. Studies of chemical changes associated with transient events using existing and newly obtained data in the line emission. Joint efforts on monitoring with the Jcnt transient team. So we are now getting into agreement of the how to say joint monitoring. So spaceborne missions can substantially increase efficiency of studies of this event. And so a relevant proposal was submitted to James Webb Space Telescope and was accepted. So, and of course, what we see now, we have to improve theoretical models. So thank you very much for your attention.
Then question from Paco Colomer. High frequency will be arrays such as AHT, NGHT are considering these studies in their programs.
Yes, well, my question, thanks, Ivar, is that there are now working groups being organized to study what can be done with a new generation EHT, NGHT, and actually the EHT itself today is able to work at this high frequency. So if there is then a consideration that these studies can be part of the science portfolio of these new facilities.
Yes, of course, this is very, very important to join efforts in these studies. But these are, how to say, in this case, I will be very, very happy to hear from you about the possibility of cooperation. But the studies of the maser transient events, so maser trigger, this should be coordinated with the maser monitoring organization. So the main driver of this organization is Ross Burns. I don't know whether you have contacted him, but this is what I suggest you to do. If you want to provide some theoretical explanation of all what is happening and what can be expected, so I will be very happy to help you. This was a review talk, but my main field of expertise, you know, that is theoretical understanding. Not only modeling, but theoretical understanding of what can happen and what is happening. Thank you very much, Paco.